Hello all, welcome to Letstute. If you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon to never miss an update from us. Do check out our website www.letstute.com for a wide range of courses on maths and science.
We are looking at some lines by Robert Frost from his poem The Road Not Taken, where he describes his journey in a forest coming to a pause suddenly when the road by which he was traveling gets diverged into two. Let's imagine, just like him, we were also stuck in a situation. So the first thing that we naturally seek out is some kind of signboard or help or direction which can help us in making the decision between the two roads. So the event that is happening right now is the traveling by a road, which we can denote as capital letter E. And clearly the two roads that we see in front of us make the outcome of this event. So let's denote road on our left as A and to our right as B. Let's say we don't have any sign that can help us in choosing between the two roads. Then we normally say that there is a 50% chance of taking either road A or either road B. Why we say this 50%? Because there is clearly no bias towards any particular road. So what we are talking about here is the chance of choosing a road. And when we talk about chance, we have to remember we talk about probability. It is the likelihood of something happening, or the chance that an event will take place, or we can say that the certainty that is involved in an event. When we hear these terms, we should be sure that we are talking about probability, and normally it is denoted with capital letter P. So probability of an event, which we can denote as P of E, can actually be calculated with a formula. So it's a ratio between the number of favorable outcomes to the total possible outcomes involved in an event. Total possible outcomes are the total options available to us, and number of favorable outcomes are out of these options, whatever we are going to consider. So options in consideration will form the favorable outcomes. So the ratio of the options in consideration from the total options will give us the probability of an event. And this has always been known as the classical way of finding the probability. So in case of two roads, the chance of taking road A is 1 in 2 and the chance of taking road B is 1 in 2 as well. That is why we say that these both outcomes are equally likely outcomes. But what about in case of three roads? So let's make three roads. We already had road A and road B. Let's say there is a third road C. Then the probability will be 1 by 3 because there are three options in front of us, A, B and C. There is only one way I can choose either of the three roads. So that's why the probability is 1 by 3. If we further go on adding these probabilities, we'll get 3 by 3, that is equal to 1. Also in the case of two roads where we had only two options, the probability was 1 by 2. If we add them, then again we get 2 by 2, that is equal to 1. What do we observe here? We observe that probabilities involved in an event, if added together, they give us a sum total of 1. And this rule is called sum of probabilities rule. But why does it happen this way? Because if we notice, when there was only one road, let's say till this point, there was only one option ahead of us and that option was favorable to us. So the ratio was 1 by 1, which is equal to 1. Now when the road got diverged into many other roads, so the probability also gets distributed. So when we add these distributed probabilities, then naturally we get a total probability of 1. Let's come back to the same situation, and this time the signboard indicates me to go to my left, that is, I should take road A. So the probability now changes. Probability becomes 100% because I am 100% sure of taking it. So this event where we are 100% sure is called an sure event, and the probability of such an event is equal to 1. So this is the highest limit where a probability can go. It cannot cross 100% or a probability of 1. Having said that, if there is a sure event, can we say that there is an impossible event also, where let's say the chance of anything happening is 0% and the probability is 0. So this is going to be a lower limit. Can such an event exist? If we say that the direction indicates that we can take either of the two roads, both the roads are good enough, but I can do it by only taking one road at a time. This means I cannot take both the roads at the same time. So that is what is the impossible event. Okay, so if both the roads are good, just by instinct, if I happen to choose road A, that means I will not travel by road B. In that case, traveling by road B will become the complementary event. And complementary event is denoted with E bar. How can we find the probability of a complementary event? We know that there is a total probability of 1. So out of this total probability, we can subtract the probability of an event currently happening. So probability of choosing road B, which is a complementary event, we will subtract from 1 the probability of traveling by road A, which was 1 by 2. So probability of choosing road B is also 1 by 2. So what do we imply from all of this? We imply that there are two extremes of probability. The lower limit is what we say the probability of 0, where there is a 0% chance of anything happening. And the highest limit is the probability of 1, where there is a 100% surety. Also, probability of an event can lie between 0 and 1. Just like in previous case, it was 1 by 2 in case of 2 roads. It was 1 by 3 in case of 3 roads. Which means either it will be more than 0 or it will be less than 1. We can show the same situation in a simple mathematical expression. Probability of an event is PE. We know that it is greater than 0 or it is equal to 0. And we know that it is lesser than 1 or equal to 1. So this is how we can actually indicate probability of an event in general. Now let us make a checklist of whatever we learned in this session.
So that's it for this session. Don't forget to hit the bell icon to never miss an update from us. Till then, keep watching, keep learning.